Hello guys, today we'll be solving a practical example on how to obtain the power function and the size of the critical region, which is also known as the significant level of the test. Now we begin with what? Example. The question says that x, which is the random variable, follows a normal distribution. X follows normal with mu equals to theta and the sigma squared, which is the variance, equals to 36. Now to test the hypothesis H0, which says that theta is equals to 100 against an alternative hypothesis H1, which says that theta is greater than 100. A random sample of size 64 was taken. A random sample of size 64 was taken, and the null hypothesis H0 is to be rejected if and only if that x bar, which is the sample mean, is greater than 101. So we reject the H0 if and only if our x bar is greater than 101. Now the question says find the power function, find the power of the test for theta equal to 99, 100, 103. And the second question says obtain the level of significance of the test, which is also known as the size of the critical region. So let's start. First of all, we write our hypothesis. The first one is the H0, which says that theta is equal to what? 100, versus the alternative hypothesis, which says that theta is greater than 100. And the critical region says that C, which is, we represent critical region as what? Capital C, which is equals to, this is the values of, this is the sample values that was drawn, and we reject this if our x bar is greater than 101. Now let's start with the power function. For you to obtain the power of the test, which is the function 1, you first of all obtain the power function, because the power of the test is the value of this power function, the value of this power function at a parameter point. So if we solve for the power function of this test, so you'll be substituting the values of those parameter point, which is in this question we have our theta to be what? 99, 103, and 100. So if we substitute the values of those values of theta in the power function, we will have the power of the test at that particular point. So and our power function is defined as k of theta, which is equal to probability of rejecting H0 given theta, which is equals to k of theta, which is equal to x bar greater than or equal to what? 101 given theta. So this is our power function. Okay. And k of theta, which is also a power function, is equal to x bar minus theta all over standard deviation over root n greater than 101 minus theta all over standard deviation over root what? N. You know, in normal distribution, this is probability. In normal distribution, in standardized normal distribution, we know that x bar minus theta, which is the what? The mean, the population mean, all over standard deviation over root n, is known as what? In standardized normal distribution, we represent this as what? z. So, which implies that the whole of this side is now represented with what? Will now be represented as z, which implies that k of theta is equals to probability of what? Z greater than what? This is the standardized normal distribution 101 minus theta all over standard deviation over root n. This is our power function of this test. Okay, so now to obtain the power of the test, I told you that the power of the test is the value of the power function, at the parameter point. So in the question we have that our theta equal to what? 99, 100 and 103. Okay, so we have this. In the question we have our theta to be 99, 100 and 101. So for you to obtain the power function, at each of these parameter points, you will now be substituting the value of this theta in this power function. So we have for 99, for theta equal to 99, we have that our power of the test, which is k of what? 99. Anywhere you see theta now, you'll be representing it as what? 99, which is equals to probability of z greater than 101 minus what? Our theta is 99 all over. In the question we have our sigma, we have our variance to be what? 36, which implies that the standard deviation, which is the square root of the variance, will now be what? 6, square root of 36, which is 6 all over what? Our n is what? 64. So we have square root of what? 64. This implies that the k of 99 will be equal to probability of z greater than 101 minus 99, which will give you 2 all over 6 over 8. 6 over 8, which if you divide, you have our z k of 99 to be equal to probability of z greater than 2.67. So we have k of 99 to be equal to probability of z greater than what? 2.67. Now the next thing is to find the area under a normal curve. Now from our table we have a area under a normal curve. So that one we find it from what? A normal distribution table. So we find the area of z greater than what? 67. For this class I will be copying it directly from the table. So if you have any question on how to find the area under the normal curve from a normal distribution table, you can drop it in the comment section. So we will find the area under the normal curve of z equal to z greater than 2.67. So the area we represent the area under normal curve as this. The area of what? Z equal to 2.67 is equals to 0.4962. This implies that K of 99 is equals to 0.5 minus 0.4962, which is equals to 0.0038. Now I used minus here. You know, in normal distribution, we have that the total area under this is the curve. This is the normal distribution curve. Don't mind my drawing. This is the normal distribution curve. Okay. Now the total area under this curve is equal to what? 1. Now, but here we are finding what? And here, from the center here to this place, here is what? From here, this is 0. And from here to this place are positive, and here are what? Negative. And we have found the area, so we look for the area of what? Z equal to what? 2.67, which means we are in what? In this direction. Okay. And we find from here, this we said from here to this place, from here is 0, and we are finding what? To this direction. Now the area from this, the total area in this curve is equal to 1, which means we have from here to this place is 0.5, and from here to here is what? 0.5. And from here to here we have found it to be what? 0.49. So for you to get the actual area of this 2.67, you will subtract it from what? 0.5. So that's why I use the subtraction in this place. So the K of 99, which is equal to 0.5 minus this, is equal to 0.0038. This value is called the power of the test at this parameter point, which is 99. Now the next thing is to what? To also find the power of the test at what? 100. So we are going to also do the same thing. We are going to do what? Repeat the same process. Just to be substituting the values of this theta in the power function. Theta equal to what? 100 in the power function. Okay, let's do that. We have that our K of theta, which is the power function, is equal to probability of Z greater than x bar minus theta all over standard deviation over root n. This is our power function, and they say we should what? Find the K of what? 100, which is the power of the test at parameter theta equal to what? 100, which is K of 100 is equals to, anywhere you see theta, you put 100, which is equals to probability of our x bar is equal to what? 101 minus theta. Probability of Z greater than 101 minus 100 all over our standard deviation is what? 6 over root what? 64, which is equals to K of 100 is equals to probability of Z greater than 1 all over 6 over 8. So if you divide, you now have that K of 100 is equals to probability of Z greater than or Z greater than 1.23, but area under Z equal to 1.23 is equals to the area under this is equal to 0.4082. So, but the area, we have that our K of 100 is equals to probability of Z greater than 1.33. But the area from the normal distribution table, the area under a normal curve of Z equal to 1.33 is equal to 0.4082. Now, so our K of 100 will now give you 0.5 minus 0.4082. I have told you why it is what? Why I use 0.5 minus 0.5 minus, because the total area under a normal curve is what? 1, and from the center of the curve, is what? 0. To the right is what? 0.5, and to the left is what? 0.5, and we will find Z equal to 1.33 is what? Moving toward to the right. So from 0 to 1.33 is what? 0.5. So you have to subtract 0.5 to get the actual value of this. You have to subtract 0.4082 from the 0.5 to get the actual value. So our K of 100 now will be K of 100 is equals to 0.0 0.0918. So this is the power of the test. This is the power of the test at parameter theta equal to 100. Okay, so that is how to go about when you're asked to find the power of the test. The power of the test is just the value of the power function at parameter point. So for this question, those parameter points are theta equal to 99 and so on. If they give you theta is equal to 150, you have to be substituting the value of that 150 in this power function. So let's quickly look at the question 2, which says the size of the critical region or the significant level. Now, the second question said II to find the significant level or size of the critical region. Now, critical region is noted as what? Alpha, which is equal to probability of rejecting H naught, given theta is true. Which is equals to probability of x bar greater than 101 given theta is equal to what? 100. So this is the size of the critical region. So you will now be substituting the value of theta equal to 100 in the power function. Note that our power function is probability of have k of theta to be equal to probability of z greater than 101 minus theta all over standard deviation over root what? N. So we substitute the value of theta equal to 100 in this power function. We have done it before. So our answer will have alpha to be equal to what? 0.0918. So that is how to solve the power function, the power of the test, and the size of the critical region. If you have any question, you can drop it in the comment section. So our next class, we'll be looking at some properties of a good estimator. Okay.